Good day, I'm Anton, and today we are going to discuss the studies of thermoregulation in lizards. The majority of the material presented in this presentation is based on the studies by Martin Muniz and John Llewellyn. And the first question we need to answer is, why do we need to study thermoregulation? Actually, there are many ways to put these studies in use. The first way is for understanding of the mechanisms of environmental adaptations. For example, we observe two similar animals. One exhibits certain behavior, another doesn't. What we can do is measure their body temperatures, the temperatures of the environment, and thus we can estimate whether this behavior is actually related to thermoregulation and whether it's important for overall temperature maintenance in animal. Another reason to study thermoregulation is to predict the effect of environmental change on animals. All we know about global warming, so what we can do is identify highly specialized species with narrow acceptable temperature range, which do not tolerate deviations or fluctuations of the temperature they prefer. And these species are likely to need management in the future. And the third reason is to explain the difference in behavior in different populations. For example, one population of certain animal basks 10 hours a day, another only 5 hours a day. And in this case, the measurement of body temperature of these animals could help us to explain if difference in behavior is due to different preferred temperature or different environmental temperature. For example, if the temperature would be the same, that would mean that their environment is different, so that it allows them to bask different time per day but have the same temperature. To study thermoregulation, we normally need to measure some thermal characteristics of an animal and its environment. The first two would be critical temperatures, critical minimum and critical maximum temperature. They are called criticals because what they do to an animal is this. Simply speaking, these temperatures are the temperatures at which irreversible damaging processes start to occur in an animal, like protein denaturation and others. One way to estimate the critical temperature, other than killing it by cooking, is this method. What we do is we place a lizard in a cylindrical container and then flip it upside down. Normally, a lizard inside the cylinder immediately flips itself back on food. However, if we raise the temperature or decrease the temperature, we will come to a point when this flipping back on food doesn't happen. That's the critical temperature. It starts to basically kill the animal. It's close to its lethal temperature. This is flipping. The other two parameters we need for thermoregulatory studies are environmental temperatures. We need to estimate the temperature of the environment. And one way of doing this is the basic meteorological method, which we can see in weather forecasts, which is to measure the temperature of the air, usually in the shade. Here you can see 5 curves of daily temperature fluctuations, presumably in 5 different sites. However, there is one better method we can use, which is more flexible and more precise. Usually we are not really interested in the temperature of the air by itself. We are interested in the temperature that a lizard can reach in certain habitat or location. For this purpose, we can use this method. We can build a model of an animal, in this case of copper, make it as close to an actual animal as we can in terms of color, shape, and so on. Put this temperature logger inside, and then we can place these models at various places outside. You can see this method is very flexible. We can put one model on a tree, one model on a rock, and detect very small differences between those locations within one habitat. Well, the actual body temperature is pretty much self-explanatory. We measure the temperature of an animal. We can insert the thermometer inside its cloaca or mouth. We can measure the temperature from the outside using, for example, this laser thermometer, or we can implant the thermometer inside an animal. And the last three characteristics are related to the preference of an animal. The first one, preferred body temperature. What we do to measure it? We place an animal into the controlled environment with a broad temperature range from very low to very high, and then we observe an animal for a certain amount of time, and usually we see a trend that an animal prefers certain temperature more often than all the others, and we assume this temperature to be its preferred temperature. However, normally we are not interested in some particular absolutely preferred temperature, simply because it doesn't make sense. There is no such thing as absolutely preferred body temperature. In nature, even if an animal has some sort of very exact preferred temperature, it never can actually keep it. So there is always fluctuation. There is always fluctuation in preference, probably daily, seasonal, or other. So instead of measuring some absolute temperature, we can measure a temperature range, preferred temperature range. We can pick up not just one particular temperature which is preferred by an animal most of the time, but for example we can pick up the central 50% of preferred temperatures that animal occupies. For example, if an animal occupies a range from 18 degrees to 40 degrees, like on this picture, we can pick up the central 25 to 35, which the animal occupies 50% of the time, and that would be preferred temperature range. And another approach to the problem is that in many cases it will probably be better not to rely on the animal personal preferences. Probably doesn't really understand what temperature is best for it. But what we can do is to test the performance of an animal at different temperatures. Basically, who cares what a lizard wants if its best performance temperature is known? Just like children going to school, they don't like studying, but who cares? School improves their performance. So in this case, we can see a sprint track built for lizard. So what was done here is lizards were released on the track at different temperatures, and then their running speed was measured. So the highest running speed is supposedly related to the optimum temperature for this lizard, the temperature at which its performance is best. Well, basically that was it. Thanks for listening. About applications of this of these methods. Well, two examples you can see in Martin Munoz and John Llewellyn studies. But basically you can do anything you want with this data. You can test whether preferred temperature is related to operative temperature, that's what exactly for example, you can test whether we should use operative temperature, or operative temperature is actually the same to the preferred temperature, and the animal actually knows which temperature is the best for it, or probably doesn't. You can compare the temperature of the environment with critical temperatures, with preferred temperatures. Maybe you can find a paradox, an animal which inhabits a habitat which has the temperature lower than its critical temperature, which would be surprising. Maybe there is some sort of mechanism which allows it to survive in this way. Anyway, thanks for listening again. I hope it was useful. I hope my English wasn't completely terrible.